Hello guys, and welcome once more to this new video on my YouTube channel. So in this video we are simply going to continue by solving June 2022 pure mathematics with mechanics paper 3. Actually in this video we are going to be solving question 5. This question 5 was actually on projectile motion. The question reads: a particle P is projected from a point O on a horizontal plane at time t equals 0 with velocity 5I plus 5 square root of 3j meters per second. I and j are unit vectors along OX and OY respectively. Find A, the Cartesian equation of the trajectory of P. B, the maximum height which P attains above the horizontal plane through O. And C, the distance of P from the point O when t equals 2 seconds. Of course, we are given G, that is acceleration to gravity, to be 10 meters per second squared. Let us actually then move into the solution of this question. The first thing we need to do is actually to come out with a figure to represent actually what is happening. So we are being told that we have a particle P which is projected, okay, on a horizontal plane actually. Since this particle is being projected, it means it is being projected with a given speed. Okay, let us call this speed to be u. And in this question we are given instead the velocity. We have to note that the speed u is actually the magnitude of that velocity actually. Yes. That is, so this particle actually P is being projected with a speed u which is the magnitude of the velocity actually on a horizontal plane actually. And since this particle is being projected, okay, with a speed u, okay, that is the magnitude of the velocity, it therefore means it will be projected forming a given angle. Let us call this angle alpha actually. Yes. So as I told you, we have to get therefore the speed actually which is u. And we know that the speed actually which is u is simply the magnitude of the velocity actually. That is, u is going to be the magnitude of v, which is equal to actually the square root of 5 squared plus 5 times square root of 3 squared actually, which gives us 10 meters per second to be the speed, okay, of with which, okay, the particle P is being projected on this horizontal plane actually. Yes. The first part of the question is asking us to get actually the Cartesian equation of the trajectory of P. To do this, we have simply to know a very important formula, that is the equation of a trajectory, which is given as what? Y equals x tan alpha minus gx squared divided by 2u squared times 1 plus tan squared alpha, where u actually is that speed, which is actually 10 meters per second actually. Yes. But we don't have the angle here. What then can we do in order for us to obtain, okay, that angle? Simply, we know the relation which says that what? Tan alpha, okay, is equals to the y component, okay, of the velocity divided by the x component of the velocity. That is, tan alpha is going to be vy divided by vx. Vy, which is 5 square root of 3, and vx, which is simply 5. Substituting those values, that is where vy is equals to 5 square root of 3 and vx, which is equals to 5 actually, we therefore get what? The tan alpha to be equals to 5 times the square root of 3 divided by 5, which gives us actually the square root of 3 actually. We have already obtained the value of tan alpha. What are we going to do next? We are simply going to go and substitute it back into this equation of the trajectory, having in mind that u actually is equal to 10 meters per second. Substituting those values, we are going to obtain y to be equal to x tan alpha, which is square root of 3, minus g, which is 10 meters per second squared, times x squared divided by 2 times u squared, that is u, which is 10 meters per second, all that times 1 plus tan squared alpha. But tan alpha is actually square root of 3 actually. For that simplifying, you are going to obtain y to be equal to square root of 3x minus x squared divided by 5, which is actually the required Cartesian equation of the trajectory of P actually. The meaning of the question is asking us to get actually the maximum height which P attains above the horizontal plane through O. So here we simply have to know the relation, okay, the formula of maximum height actually. H max is given as u squared sine squared alpha divided by 2g. But we don't know sine, we don't know actually sine alpha, but we can get it since we already know tan alpha. Knowing that tan alpha is equal to the square root of 3 divided by 1 actually, we can come out with our small triangle. We actually represent actually this relation. That is, we know that tan, okay, alpha is actually opposite divided by adjacent. That is opposite, which is square root of 3 divided by adjacent, which is 1, from which we can therefore get actually the value of the hypotenuse, which is actually 2. by doing what? Square root of 3 squared plus 1 squared, or that square root actually, we get therefore the hypotenuse to be 2, from which we can therefore obtain sine alpha, which is opposite divided by hypotenuse, that is square root of 3 divided by 2 actually. From which we can also get, of course, as well, the value of cos alpha, which is actually what? Adjacent divided by hypotenuse, that is cos alpha is equals to a half actually. We can therefore come and substitute the value of sine alpha in this formula for the maximum height. Substituting the value of sine alpha, we are going to get h max to be equals to u which is 10 meters per second squared, 10 meters per second, we square that, then times square root of 3 divided by 2, all squared actually, divided by 2 times acceleration to gravity, that is 2 times 10. Simplifying it, we are going to obtain h max, that is the maximum height, which P attains above the horizontal plane through O, to be equals to 3.75 meters actually, which was actually what was being asked in the B part of the question actually. Yes. Let us move into the C part, that is, we have been asked to get the distance of P from the point O when t equals 2 seconds actually. We have to note that actually the distance actually is simply the magnitude of displacement. So getting the displacement and finding its magnitude, we therefore get actually that required distance actually. We know that our displacement is actually xi plus yj meters, where x and y are simply the components of the displacement. That is, x is simply the horizontal component of displacement and y is the vertical component of that displacement actually. Putting those values, that is x and y, we get the displacement to be equals to ut cos alpha I plus ut sin alpha minus a half dt squared actually. Substituting the values of u, t, and then cos alpha and sin alpha, of course, as well g, we get the displacement to be equals to u, which is 10, times the time, which is 2, times cos alpha, which is actually half, I, plus u, which is 10, times time, which is 2 seconds, then sin alpha, which is the square root of 3 divided by 2, minus a half, times g, which is 10, times the time, which is 2, we square that, give us the j component actually, from which you can therefore conclude that the displacement is actually equal to 10I plus, open bracket, 10 times the square root of 3 minus 20j. Yes. Finally, we can therefore obtain the distance, which is simply the magnitude of this displacement, that is the square root of 10 squared plus, open bracket, 10 square root of 3 minus 20 squared, which actually gives us 10.353 meters to be actually that distance of P from the point O when t equals 2 seconds. Thank you very much for watching this video, and remain tuned for the very next interesting video concerning mechanics. Thank you.